Welcome to ECS Education Academy, where science meets system. Today, we're diving into a critical reappraisal of cannabis, lipids, and brain flow. We'll be revisiting the relationship between cannabis, cerebral perfusion, and lipid biology, and critically reappraising the findings from AMEN's SPECT imaging studies. First, let's summarize AMEN's SPECT study findings. AMEN's study analyzed over 26,000 SPECT brain scans, providing a large data set for observation. A key finding was the observation of reduced cerebral blood flow in cannabis users, with hippocampus perfusion strongly predicting marijuana user status. However, AMEN's study had limitations. A cross-sectional design prevents causal conclusions, severe selection bias was introduced by using neuropsychiatric patients, and there was a lack of control for critical factors like lipid status or diet. Now, let's explore the crucial role of modern PUFA ratios and their link to neuroinflammation. Modern omega-6 to omega-3 ratios are severely imbalanced, a significant shift from the healthier, lower ratios maintained in ancestral diets. This high omega-6 intake leads to membrane rigidity, loss of DHA, and drives chronic neuroinflammation and endocannabinoid tone. Understanding how lipids control brain function is fundamental to this discussion. Approximately 30% of the brain's dry weight is composed of polyunsaturated fatty acids, highlighting their critical importance. DHA is crucial for fluid cell membranes and CB1 receptor regulation, supporting synaptic efficiency. In contrast, AA dominance leads to stiff membranes and pro-inflammatory signaling. High arachidonic acid, or AA, leads to excessive 2-AG signaling and chronic CB1 overstimulation. This suppresses neuronal firing, reduces metabolic demand, lowers baseline perfusion, and results in poor vascular responsiveness. Modern PUFA imbalance causes NVC failure. Healthy brain coupling ensures blood flow increases with neuronal activation, but omega-6 dominance weakens both neuronal signaling and endothelial function, leading to a blunted perfusion response. In healthy brains, THC causes mild CB1 activation and maintains stable cerebral blood perfusion. However, in omega-6 dominant brains, where CB1 receptors are pre-overactivated, THC strongly suppresses metabolic demand, severely exaggerating the perfusion drop. The hippocampus, with its highest DHA concentration, is particularly sensitive to PUFA ratio imbalances. Its high metabolic demand and rich CB1 expression make its specialized vascular network extremely vulnerable to constriction, severely exaggerating THC's perfusion-dropping effect. AMEN's SPECT findings accurately reflect hypoperfusion changes, but the data reveals the effect of THC on dysregulated modern brains, not healthy ones. Severe PUFA imbalance is the critical underlying factor. To correct this terrain, we must address the omega-6 to omega-3 ratio imbalance, restore DHA levels, support vascular health, and rebuild specialized pro-resolving mediator production capacity. Only then can we truly reevaluate cannabis's impact.